Namaste guys, in this free course you are going to learn how to plot awesome 2D animation and 3D animation graphs in Jupyter Notebook by using Python. So it's a quite simple interesting thing. Even if you don't have any knowledge of how to plot graphs in Python, this course is basically for you. So don't worry about it. All codes are provided, link in description. If you face any kind of doubt, feel free to ask. I will simply update the code link in description. Okay, so basically you will go my blog and you will read it there. If you have faced any issues and doubts, simply just tell me and I will just update the code. At the end of the course, we will learn how to do some awesome projects for mechanical engineering because I'm a mechanical engineer. So that's for all. Thanks for watching and have a great day. Namaste guys, in this video we are going to learn about basics of Matplotlib. Okay, so first thing that we are going to do is in this chapter that we are going to learn how to plot a simple graph. So in school times we know like we have a data that hey x is this and y is this and plot the graph. So we are going to do that simple example. So first thing that we have to do is import our libraries. So import matplotlib dot pyplot as plt. Okay, and after that now in school what we have done is x equal to bracket, let's say I have data of 1 5 6 7 8, and on y-axis I have data of 8 4 5 2 3. Okay, now to plot the graph it is very simple. All you have to do is plt dot plot type x comma y. After that, press Ctrl Enter, and voila, your graph is plotted. You see, it is quite easy. Now, let's try to understand this code. So basically, what I have done is, I have first import my graph library, that is matplotlib.pyplot as plt. The reason it is plt, so I can use functions that are present in matplotlib. Okay, so plt dot plot means that, hey, in matplotlib there is a function called plot, so I call the function plot and I give two parameters x and y. Here x and y are arrays. The reason I type square brackets, just to know that these brackets are called square brackets. Okay, the reason I choose because in matplotlib you basically input array. Okay, so this is a very simple graph. Okay, now let's try to do one more example. Okay, so let's copy this code and let's make it simple. Plt plot, uh, instead of giving x and y, I will simply give 1 5 7 8 9, and if I press Ctrl Enter, you can see my graph is plotted. Just to be observed that this 1 5 7 8 9 is the value along the y-axis. Okay, not along the x-axis. Now, what are the some common mistakes done by the beginners? Currently, I'm using in Jupyter, but if you are using PyCharm or other, then you also need to have another command, that is plt.show. If you don't type this command, it will not show the graph in case of non-Jupyter users. Okay, so make sure that you know that. Last time when I tried to do it, my graph was not plotted because I doesn't have this command. Okay, so this is the first two basics example. Okay, now we are going to learn how to draw multi-line plots. As you can see, previously we have drawn a single line plot graph, but what if I want to draw multiple line plot graph? So how can I do that? Okay, so again I will call this library as a syntax. Okay, now to draw a multi-line plot, I need multi-line data as well. So here's the thing how to plot it. So let's say x 1 comma 2 comma 3 comma 4, y let's say it is 9 comma 8 comma 7 comma 4. Now let's say x1 equal to uh, 4 comma 5 comma 6 comma 7 and y2, sorry, y1 equal to 9 comma 6 comma 3 comma 4. Okay, while making the graph, always make sure that the number of elements is same. For example, if I have less value here and greater value here, the graph will not plot. Let me tell you what I mean. For example, here you can see this x contain 5 elements. Okay, suppose I remove one element, and if I press Control Enter, you can see I'm getting error because uh, they are not equals. Okay, so make sure they have the same first dimensions, else it will not plot. So press Ctrl Z and Control Enter. As you can see, it's worked fine. Now to plot a graph, multi-line plot, it is very simple. All you have to do is plt dot plot. So press x comma y comma x1 comma y1. So if I press Control Enter, you can see my multi-line plot graph is plotted. Now here's a problem. Which one is the first one and which one is the second one? So these things are called styling. I will cover later onwards. Okay, but just to know that this is how you plot a multi-line plot graph in Python. Namaste guys. In this video, we are going to learn how to add grid, controlling the axis and adding labels. So let's see how to do that. So I will just click on plus code, okay, and click on here and press Control P. So what you have to do is simply plt.grid true. So let's try to understand what will happen if I don't add. So if I press Control Enter, you can see this is a simple graph, nothing special, and the background is totally white. But if I add plt.grid true, you will notice that now I have some grid on background. This is sometimes quite useful. For example, if the grid is not there, it is difficult to know exactly what is the exact value of it. Now by looking at it, you can say exactly this is value 5. Okay, so this is the advantage of grid. It is easy to read the graph, okay, by adding grid. So the next thing is adding the axis. So you will say what the hell is axis here. So you can see this is x-axis and this is y-axis. But suppose your client say, hey, I don't want my axis start from 0, I want it to start from some other points and at some other point. So how can you control that? So let's see. So we would have plt dot axis bracket square brackets. Let's say I want that my x-axis start from -1. So let's say my x-axis start from -1 and it will go up to 10. Currently my x-axis start from 0 and it goes up to 8. Okay, but I am changing to -1 to 10. Similarly, let's start my x-axis from 0 and let's say it goes up to 15. Currently it is going up to 8. So 15. So if I press Control Enter, you can see for x-axis it is starting from -1, but for y-axis it is starting from 0, and this the top one is the 15. So you can see you can control it, and you can see your graph easily. There are times when you need to know. There are times, for example, when your graph is too big and you want to see it clearly, you will use axis. There is something called x limit, y limit. We will learn about it later onwards. Now the last thing is labels. So what are labels and why I need to add it? So here you can see along x-axis, there is nothing written. I mean, what is represented by x-axis? Okay, what is representing by y-axis? So I don't have any idea. So to add the name along x-axis, we use something called labels. Okay, so if I click on plus code, let's copy this code, paste it. So what we will do, let's say I want to label x-axis. So it is very simple. PLT dot x label. Let's say label it x-axis. Similarly, PLT dot y label. Let's say it is y-axis. So if I press Control Enter, you can see uh, they are given some labels. And if I want to add title of the graph, you can add simply type PLT dot title, and let's say title of the graph is simple graph. So if I press Control Enter, you can see I got title, y-axis and x-axis. So this is what we have learned so far, how to add grid, axis and adding labels. If you want to learn about more, check out my blog link in descriptions. Okay. Namaste guys. In this video, we are going to learn about legend. So legend is not, history legend or religion legend. It basically means to identify graph. I know some people will not getting it. So let's see by example. So let's import our libraries. Import matplotlib dot pyplot as plt and import numpy, numerical python as np. So let's say t equal to np dot line space 0 comma 10 comma 10. Don't worry, I will explain this line means. After that I will do plt dot plot t comma t double star. Double star means raised to the power. So t square is basically means t square. Okay, and add label. Let's say it is square and plt dot plot t comma t and label linear. So if I press Control Enter, you will see this is simple graph, but no legend is here. But if I add plt dot legend and press Control Enter, you can see now I can easily identify which one is square line and which one is linear line. So this is the purpose of legend. Now suppose someone say, hey man, I want to change the location of the legend. So how can I do that? Simply go to the legend, type LOC and type whatever you want, upper left. There are some standard names of it. So I recommend please check out link in description to see what are the standard names and how to use as per your requirement. So if I press Control Enter, okay, it is not happening. Yeah, yes. So basically I choose the wrong name, that's the reason. So you can see now it is here. So by default it will go to the best space or best fit. Okay, by default in legend it will go to the best fit. So if I press Control Enter, so this is how it look like. So now let's try to understand what the hell this means. T dot this means. Okay, so if I press plus code, so np line space means, hey, I want that you start from counting from 0, go up to 10, and there's a difference of 10. So if I press T and press Control Enter, you can see it start from 0 and incrementing as 1.11, 10.11. So the question is why it is 1.11, 2.22. So it is so you can also do it. Let's say for the sake of simplicity, let's enter 1 and also this. So now you can see you can easily verify. So basically what is happening, hey, that what I'm saying is that the starting point is this, ending point is this, and there should be 10 number of points in between the starting point and ending point. So this is what line space mean. For example, if I increase its value to 100 and press Control Enter and press Control Enter, so you will see 100 points. So this is what line space mean. So this is the starting point, one is the starting point, this is the ending point, and this is defined how many number of points you want. You can see my graph is also reaches to 100. because I have defined 100 points. But for the sake of simplicity, 10 points is fine. So press Ctrl Enter, and this is how it looks like. So I hope now you can understand. Now basically what I have done also here, I basically add a label square, linear. You can add any other name. So to identify which line represent what. Okay. So it is not quite simple or easy. To see the graph and tell, hey, what line represent what. And even if you look at the future or send this graph to another, they can also verify what this line present what. Okay. So that's for all. Namaste guys, in this video we are going to learn about styling in graphs. So from here onwards we are basically going to learn, for example, how to choose colors or line spacing, etc, different kind of things. So let's start. So first what I'm going to do is basically I'm just going to copy this same code. So first thing that I'm going to learn is I'm going to teach how to do coloring. For example, if I press Ctrl Enter, you can see this is the color of my graph, blue and orange. But if someone say, hey man, I want the pink one color. So how you can add or some other colors. So let's say I want to change the color. So in Python PyPlot, there are some inbuilt, graph colors with small annotation. For example, if I type C, sorry, and here let's say I add B, and if I press Control Enter, you can see that the color is changed now. Now, suppose somebody say, hey, I want to add pink color. So how you can do that? So basically, you can see here that I have choose a pink color and this is his X value. So I will just simply copy it and I will go here. Make sure to type hash first. It means it is a hexacode and press Ctrl V. So if I press Ctrl Enter, you can see I'm getting the pink color. Okay. You can add other parameter or variable as well. Okay, different ways as per your requirement. Okay, so that's for all for the coloring. Now let's talk about how do we add basically different kind of line. For example, this is a straight line but I want dotted lines or dash lines. So how can I do that? So press copy and paste here. Let's remove this. Instead of that, type double space and here type dash dot. If I press Ctrl Enter, you can see my graph plot line are changed. You can see the standard ones, what are the varieties available. Check out my blog link in descriptions. I provided the link so you can see what are the different other colors or variations are present. So we have covered two topics. One is coloring, other is dashed line. Okay. Before I move forward, let's talk about some beginner level mistakes done by the beginner. Suppose you can see label is written here. If I copy this and let's say cut this and paste it over here and press Ctrl Enter, you will see it will not work. The reason is that label always should be at the end, okay, and color should be after these two things, x and y values. So make sure that you remember that. And same goes for here. Label always should be at the end of it, else you will face error issues. So let's press Ctrl Z and Ctrl Enter. So that's for all. Namaste guys. In this video we are going to learn how to do scatter plotting in Python. Okay, so let's start. So first we are going to import our library. So matplotlib.pyplot as pld. Okay, now let's define a variable called n and let's say it is 100. Now what I'm going to do is x equal to okay, I need one more thing, that is import numpy as np. So np dot random dot uh, rand n, and similarly y equal to np dot random dot rand and plt dot scatter x comma y. So if I press Control Enter, you can see the scatter graph. Now, first question that arises in your mind: why I will use a scatter graph? Suppose you want to see what are the prices changing, or uh, you want to see where are the things are expensive, or you want to differentiate something. So scatter plot is the best approach for it. Okay, or you want to visualize how the data is, whether it is cluster data, it is distance data or something else. At that time scatter plot is best. Okay, in later on videos I will show you how I will use scatter graph, okay, to estimate the pricing of a house. Okay, it is a machine learning program, but I will just only teach you the graph plotting, not the machine learning. But watching the graph you will realize, oh yeah, in that way you can easily see. So it is just a simple, just a surface. I will talk about deep details later onwards. So before I move forward, let's see some other thing else. Let's add this other parameter, let's say scale, and let's say scale is 10 times whatever is the sorry, x star y, and let's copy the scale, cut it, sorry, and move it here, and after that plus comma plus scale equal to scale. If I press Control Enter, okay, if I press Control Enter, so you can see now here are the dots are short and here are the dots are bigger. So you can easily say, hey, whatever going on this side, they have bigger dots. So you can say that they have bigger magnitudes. Okay, so this is what it does. Now let's add another parameter. Let's say colors and p dot p dot random dot rand capital M and comma colors equal to colors. Now Control Enter. Sorry, not colors, it is the C. Press Control Z. I press Control Enter. So you can see now different color is showing on. Okay, so you can visualize what color it is. Just to know for deep detail how they are practically using, like I will teach later onwards. So this is just a beginner friendly course. Just to know, currently right now we are just learning how to plot graphs. To understand how they are used in real life, we will move on later onwards when I will do complex things, for example animation, data visualization using pandas. At that time you will understand, oh yeah, then at that time they will understand how to use it. Okay, but just right now just understand how does this work. Okay, so this is all for the scatter plot. So in this video, we are going to learn how to plot a pie chart in Python. So let's start. So first thing that we have to do is import the Matplotlib. Okay, matplotlib.pyplot as pld. And after that, we have to define what kind of data I'm going to show. So basically in pie chart, as we know, basically what we show basically about data and the labels. Okay, so this is the two things that we need to define. So let's say x, so I need to add the data, for example 20, 30, 50, 60. Okay, and that's all. And after that I will type y equal to, now in case of y I will add labels name, so it is basically a string. Okay, so that is the reason I'm using quotes. So let's say milk, and after that let's say fish, cake, money. Let's add something eating. Let something eat. Let's say chips. uh, I'm hungry now. And after that I will type plt dot py x comma. As I told you earlier, in pie chart basically what I'm plotting is labels. Okay, data and labels, so you need to add a parameter called labels equal to, so what's the labels value? It is y. After that press control enter, and it's showing some error. It's saying it's say matplotlib. Basically his whole name is matplotlib, so my bad. So control enter. So you can see my graph is showing. So you can see the data. What if I want to a little explore view of this? So what I can do, control copy, click on plus, press control V, plt dot explode, and control enter. Matplotlib nodes attribute of explode. We can also plot explode graph, for example explode pie chart. For example, just I want to move this one little bit extra. So how can I do that? Okay, let's see what I mean. So press control V. So this is my graph. So I add a parameter called explode and enter the matrix value. So chips value is 60. So let's watch carefully what I'm doing. 0 comma 0 comma 0 0.1, and there are total 4 parameters, so 0.2. So I will go here, type comma explode equal to explode, control enter. So you see that this part is move away. So this is what is a. So this is what is a explode graph, explode pie chart. Okay, for some reason my runtime disconnected, so it is connecting again. So you can see, so higher the value of this, higher will be the distance from the pie chart. So you can show it more accurately how it look like. And as you can clearly see, it is not showing my data, it is just plotting the graph. So how can I show the data? To show the data is quite simple. What I will do is uh, auto PCT percentage and percentile 1.1 F percentile, control enter. So you see my data is showing is percentage right now. So basically automatic percentage is what basically means, and 1.1 basically how much long your data wants. 1 means a one significant, and zero point 0.1 means up to zero point 0.1. If I enter the value of zero point 0.2 for example, so it will 18.8 something. So let's see what I mean. You see 18.75, but for the sake of simplicity 1.1 is better. I highly recommend you to check out my blog link in description to understand how does this work. Okay. Now we have learned about how to plot different kind of graphs. Now let's do some tests. So first we are going to plot a sine graph. So let's see how to plot it. So import matplotlib dot pyplots as plt. Now import numpy. The numpy because I'm going to use trigonometric function, for example sine, cos, that's it. So that is the reason I'm calling numpy. Import numpy as np. Now, first thing that I'm going to do is I have to define t. T is basically means theta angle range. Okay, so from where my theta angle start. So let's say np dot line space. It starts from 0, uh, goes up to 360, and there are 360 points in between them. Okay. After that, I will define x, that is let's say np dot sine and t. Now plt dot plot t comma x. If I press Control Enter, okay, I I make a spelling mistake, so sorry for that. Now you notice the graph is not what we learn in school. The graph is not what we know 0 to 360 degree. So where is the issue? Okay, here's the thing. If you watch my videos carefully, then you will know that by default, every value that you give in trigonometric functions are in radians. So it is basically given in radians. So I need to convert into degrees. So how can I convert it? By simply typing np dot radians. I know. It is confusing that I am converting into degrees and I am typing radians. Yeah, it is right. You have to write this. Okay. So you see, so this is the graph that you have learned in school. Let's add grid, plt.grid, and let's make it on. Control Enter. So this is the graph. Uh, but my graph looks small. So let's increase the size. So plt.figure and fix size, comma 5, 10, comma 10. If I press Control Enter, okay. So this is how my graph look like. A question arises: what is the difference between figure and axis? I will cover later onwards, okay. But for now, just remember that I'm just simply teaching how to plot a graph or some exercises. When we go to advanced level, okay, then I will show you how to use different kind of things, and subplots will also be covering later onwards. So let's copy this and let's Control V. So we have plotted sine graph. Now let's try to plot a spiral here. So how to plot a spiral? So I need two parameters x and y. So one more thing, a spiral has a changing value. It is not a fixed. So I need to change my spiral value as well. So I have to add a new value, that is r. R basically means radius. Okay, np dot line space. Let's say it is start from 0 and it goes to 360, and there are 360 number of points. So it is radius, and the uh, above one is it is theta. Okay. Now what I'm going to do is I will start r star. Similarly, I will just copy this and paste it here, and is r star. Instead of sine, I will type cos, and instead of t comma x, I will type x comma y, and if I press Control Enter, so you see my graph is plotted, but it looks quite ugly. So what I will do, I will type plt dot axis uh, equal. So this is how my graph look like. Let's remove this plt grid for a second and press Control Enter. Let's increase the range. Instead of 360, let's make it 1080 and Control Enter. And also increase this value to 1080. So you see now my graph looks great. If I press Control Enter, so this is my spiral graph. Okay. Now it looks, something like spiral. Yeah, it is a spiral graph. Now I have plotted two graphs. Now here's a task for you. You see, I have plotted this paragraph. Now suppose I want to plot a circle. So pause the video. Here's the code. You have to do some little changes here, and you can plot a circle graph. So try to do your own. Okay. So I assume you all guys try to do it. So let's see how to do it. So just simply copy paste the code. It is quite simple. Instead of changing value, because in a circle radius is fixed. So enter the value of radius whatever you want and press Ctrl Enter. You see, and one more thing, that here the angle is 1080. Uh, is there need of 1080? No, only 360 degrees is required. So this is how we can plot a circle in Python. It's quite simple. Okay, nothing science-fi. It's easy. You can add labels plt.x label x-axis axis plt.y label y-axis plt.title circle, press Control Enter. So you see, I have added labels and titles. So it is quite simple. Okay, nothing science-fi or complex thing. So now here's a task for you. So basically, I taught you how to plot graphs of various, sine and spiral. How you will plot a equation, for example, ABC x square plus y square. Suppose I say, hey, plot the graph of this one. How will you plot it? Suppose I give you equation a parabola or ellipse or some other quadratic equation, and I will say, hey, plot the equation. So how will you plot it? So it is also quite simple. I recommend first try your own. After that, just see my code. So in that case, first of all, I need to know what is my equation that I'm going to plot. So let's say I'm going to plot x square minus 5 times x plus 5. Suppose I'm going to plot this equation. So how I'm going to plot it? So first I need to know the range, in which range I'm going to plot my graph. Suppose I'm going to plot my graph 0 to 360 and 360 number of points. So suppose this is x. Okay, suppose this is my equation, and in equation I will type x square. Basically this double star means raised to the power. So x raised to power 2, it means x square minus 5 star x plus 5, and I want to plot my y along x. So instead of this, I will type equation and I press Control Enter. So this is my graph. No, not looking interesting. Doesn't look much interesting, right? Yeah, looks quite ordinary. Equation y. See, ways I have done some mistake, I guess. Let's take the range to 1. Press Control Enter. So this is my graph. Let's add some more parameter to make it little bit curvy thing. 5 star x 5. Let's Control Enter. So this is the graph. So in that way, you can just plot the graph as per your requirement. The main aim is just to show, hey, how to plot the graph equation. Change this title to graph equation. Graph equation. So that's for all. In from now on, we will increase the complexity. So from now on, I will teach you how to do animation, do the interactive graph plotting, etc., etc. So now on I will recommend that you make sure that you open your ears carefully and listen what I'm saying, because if you skip anything it will create issue later onwards. So that's for all. Namaste.
Namaste. In this video, I will tell you how to use fluid equations to plot streamlined flow in Python. So let's see how does this code work. So first of all, I'm going to use Matplotlib Qt, import numpy as numpy and matplotlib.pyplot as plt, that is basically going to plot my graph. Here I am creating a function that is def flow equation x comma y. Here x and comma y are my variables. Here u comma v are the velocity equations in x and y directions. Just remember, if you don't understand what is here u and v, just buy any standard books of fluid mechanics and read the chapters fluid kinematics. You will understand what's going on here and what is mean by u and v. Now here L is the number of here L is basically 8 and M is 101, that is number of interval. Basically here x1 is minus 8 to 8 and the number of interval is 101. I am basically putting these values here. Okay, now I am going to create a mesh grid x1 to x2 and u comma v flow equation, and this is velocity LW. Now a question arises in your mind, what is this vals and LW is doing here? So when I plot this equation, for example run this, as you can see here the thickness is high but here the thickness is low. So basically LW tells the line width, that is the thickness. Higher the value of LW it shows means higher the magnitude of my velocity as here. Okay, and lesser the thickness means there is low velocity at here. Velocity magnitude, remember the thickness is showing the magnitude of the velocity. Let's try another equation. Suppose this one. Now run this code. As you can see, this is the flow equation. Okay, I hope you like this video. If you have any doubt and queries, make sure you comment. If anybody can support us financially or can donate, this channel will be very thankful to you. If anybody can donate this channel, so I will be very thankful to them. Thanks for watching and have a great day.
Namaste guys, in this video we are going to learn how to make 2D graph animation in Jupyter Notebook from scratch. Okay, so let's start. So before I start this tutorial, make sure that you have installed ipyWidgets. A simple command is pip install ipyWidgets. Okay, so you can install via cmd. Okay, anaconda cmd. So first I import ipyWidgets as widgets, import numpy as np, import matplotlib.pyplot as a plt. So this one is basically going to plot our graph. This one is for trigonometrical functions that we are going to use in our program, and this one is going to create this animation part. Okay, after that I have create a function called theta in which I have included a parameter called t1. After that, here you can see I have defined the figure size or graph size is it is 10:5. Okay, 10 comma 5. And here you can see t and p dot line space 0 to t1 equal to comma 20. So line space basically defined 0 to t1, and there the number of gaps, uh, gaps between them is 20. Okay, so this line is present total t. Just remember that t1 is going to be updated, and it will go to the maximum value of 360 degree. Okay. After that, I have created a function called x, that is np dot sine np dot radius t. A question has your mind, why I have tried np dot radians? By convention, whenever you type give or angle to sine, it will take as a radians. To convert into degrees, you have to type np dot radians. I know it sounds weird that to convert into degrees, I have to type radians. Yes, you have to type radians to convert into degrees. Okay. Now after that you have to type plt.plot t comma x, okay, to plot the graph. So this is amplitude and this is degrees, and I've given the label degrees and amplitude. After that I have import this, I have called this widgets interact. First define the function name. After that my parameter, that is t1. Okay, widgets dot play. I have defined the minimum value, the maximum value, and the number of steps. Lower the number of steps is better the speed of the animation. If I increase the speed of animation and shift enter and click on play, and mm, sorry, for example, if I make it 360 and make it 10 and shift enter and make it play, as you can see now the graph accuracy is more higher and it will take some more time. Okay, so with that you can increase or decrease the speed of time as per your requirement. And if you want the code, check out the code link in description. Okay, as you can see, I in this time I have not defined steps, so it is taking a very long time to plot the graph. uh, it is going to be take a lot of time, I guess a 2 minutes or more. But if your complexity is high, it will take a more time. uh, I also created this one. Okay, so if you are from a mechanical engineer, okay, then you will know where this graph from. It is from engineering mechanical vibrations. So it's basically the calculating the graph of plotting the graph of vibration with respect to time. Okay, so I'm currently creating a course for mechanical engineers, so you will see in the future. And here's this code. And if you want the code, check out the blog link description. And here you can go to my blog and check out my other cool things. For example, other code, for example, Python tangent to the curve. It is an interactive one like this animation, so you can definitely check out my other uh, tutorials. And if you are from mechanical engineer, I have done a plenty of coding for mechanical engineering. And if you are from a computer science background, then here are some codes I have done for OpenCV and my projects. I hope that you're going to like it. So make sure that give it a try. You might like it. And I hope you learned something from this video. If you have any kind of doubts and queries, feel free to ask in comments. Okay? And thanks for watching and have a great day. Namaste. Namaste guys. In this video, we are going to learn how to make the spiral animation in 3D in Jupyter Notebook. Okay? So let's start. Okay, so to make this animation we need to import some module libraries, for example ipy widgets. Okay, so this one is basically create this thing. Okay, so import ipy widgets and import widgets. Okay, after that we will import from mpl toolkits, import mplot 3D. We need this one to plot 3D graph. If I don't import, I can't able to plot 3D graph. Okay, import numpy to use my mathematical functions. Okay, as np import matplotlib to plot the graph. Matplotlib dot plot as plt. So we are going to create a function called theta t. That is basically my parameter. And first I have to define my the graph size. How big is this graph going to be? So type fig plt dot figure and type fig size. Fig size basically tells what is the size of my figure. Okay, for example 10 comma 15 is the size of my of this figure. After that I will type ax axis plt dot axis, and we will type projection equal to 3D because it is a 3D graph. Okay, uh, if you are not familiar with 3D graph, I highly recommend that you for a moment just check out the blog link because I have explained a lot of details there, so it is quite useful for you. After that I will type the axis name, for example z axis. So z axis is the one that goes upward. Okay, so this one is the z axis. And okay, so z, so np dot line space 0 comma t comma 500. After that uh, x equal to np dot sign z, y equal to np dot cos z, and ax dot plot 3D, and just type the name of the axis x y z and enter the color name as per the requirement. I am using red color, but if you want to use any other color you can do it. And plt dot show because I want to show the graph. Just to note that plt dot show is necessary for PyCharms. And one more thing, that ipy widgets only work in Jupyter notebook, not in PyCharm. So sorry for those people. After that I will type widgets dot interact bracket. Here we will name the function name, that is theta t widgets. Don't worry, I will explain the code. Play minimum value, that is 0, maximum value, that is 15, and done. So let's try to understand how does let's run this code. After that we will try to understand how does this code work. So theta comma, and if I play this code, yeah, it's working now. And one more thing we can do is now let's try to understand how does this code work. So I have already explained all these parameters, so I'm not going to explain again. Now this one is basically defined by the figure of the size. For example, if I increase to 20 and shift enter, you can see my graph size is getting big. So it is good for if you want to do presentation or something else. Again, it's up to you. I prefer 10. After that, let's see the parameters. So this one is basically plot 3D graph. ZXY already explained. This one is Z axis, X and Y axis respectively. Uh, these are the functions, and these will plot X, Y, Z axis. Now this one, the important one, widgets.interact. So I have created widgets, that basically interactive widget. So in interactive, first I have to define a function. Okay, so my function is theta. So what I am trying to play or animate. Okay, so I'm trying to change the value of t, that is the parameter of t. Okay, 0 to t. So with time my t will change. Okay, t widgets.play. So this is basically the thing that is playing in my animation. So here I have tell that the minimum value is 0 and the maximum it can goes up to 15. So simply you can click on play and you can get the animation. And if you want this animation will run forever, simply click on this icon loop and click on play. So your animation will run. Okay, and I highly recommend that you check out my blog link or my GitHub library for more cool codes and better understanding. And I hope you learned something from this video. If you have any kind of doubts and queries, make sure that you ask in comments. Thanks for watching and have a great day. Namaste. Namaste guys. So in this video, we are going to learn how to make this interactive graph visualization of trigonometric functions. So I guess you all learned these trigonometric functions and graph plotting in your 8th or 9th standards. Okay. So in this basically we are going to learn how to plot this in interactive way in Python. So basically you can see my triangle changing its face in a circle, and here is my sine graph as per the angle. Here is the angle is 35 degree. So if I make it 322, you can see my graph plotting. And just remember that in my case, the 0 degree starts from here. Okay. So let's see how does this code work. So first thing I have to do is I have import Matplotlib and NumPy and IPy widgets. So Matplotlib is basically used for graph plotting, NumPy for mathematical calculation, IPy widgets for my interactive this slider bar. After that I have so here you can see that I have defined a function called f, and there is a two parameters called r and t. So r is basically means radius and t means theta. So basically means angles of degrees. So after that I have defined g.plt.fixed size. It is 4 comma 8. It means that my graph size is 4 8. Okay, it is basically the scale size. After that basically as you can see there are two graphs here. Okay, and this thing is called subplotting. So to define subplot I have typed g for my figure size 4 comma 8. Okay, remember it is 4 and this is 8, 4 comma 8, and I have typed something called 211. So 211 means two graph first column first row. Okay, two graph first column first row. 212 means two graph first column second row. Here you can see. So basically to define where are my graphs will plot in my fixed size. After that I have defined theta np.line space 0 360. Okay, so this code of line will plot my triangle, and this line basically will plot my circle. For those who want to understand how does the circle line of code work, I highly recommend check out my blog link in description, in which I have explained how to plot parametrical circle in Python. That is more detailed video than this, so I highly recommend check it out, because explaining the same concept again and again is a waste of time. After that I have, you can see here I have type AB. So basically as you can see, so x and y basically tells me, x tell basically means the base and y basically tells me the length, but I want to plot this in graph. So what I can do is I have typed AB. So basically a 0 0. So this point is 0 0. This point is x comma 0. As you can see, this point is x comma y, and this point is 0 comma 0. And you can also see what are its length. Okay, base length of triangle, height length of triangle, and hypotenuse. After that this graph is over. So this is the first graph. Now let's talk about the sine graph. For sine graph, what I have done is I have defined theta np dot line space 0 to t 360 degree. So t is basically defined by this slider. So what does it mean? Just 0 and goes up to that value where it is defined by our slider, and 0 to 101. Okay, 111. So it will plot the graph up to there. So if I go to 360, so it will plot my graph up to 360 degree. Okay, and After that, I have defined S RP and P dot sine radians theta. Basically, to tell my graph, whatever the value you are getting from theta, convert it into radians. It's converted into degrees. Okay. I know look quite odd why I have written radians, but I'm talking about degrees. So remember that if you type degrees, for example, let's say cut it degrees and enter. So if you type degrees, you will get graph like this. Just you know, in Python by convention, whatever the value it takes in radians. So you need to convert into degrees. To convert into degrees, you need to type np dot radians. Okay, that is the reason I have write. I know it look quite odd. Why radians, not degrees? But I don't know why. But it's convention here. So it's syntax. So after that, I have typed axt dot plot theta comma s. Okay, remember theta dot s second two graph, first column, second row, and I have typed print x comma y so I can get the height and values. After that, at the end, I have defined my function f that I have defined here, and r and t. R basically means my radius. T means angle from 0 to 360 degree. Radius vary from pi to 30. Okay, and here I got the results. You can play with it, and you can also make any other graph. For example, if you want to plot tan graph or sine graph, you can also make it as per your requirement. It is quite fun, and if you want the code, check out the blog link in description, and make sure that you give us some rating on GitHub so that it will encourage me to uh, make more content like this. I will be really appreciate. And thanks for watching. If you have any kind of doubts and queries, make sure that you ask in comments. Thanks for watching and have a great day. Namaste.
Namaste. In this video, we will talk about parallelogram law of vectors in Python. So while doing this program, we are going to use NumPy, Matplotlib and a module called Math. So we know that the parallelogram law of vector tells when two forces of certain magnitude with a direction applied on a body, it gives a resultant magnitude at a certain direction. So here I'm going to use two forces a of a magnitude one is minus 10 Newton and another is 8 Newton. We know that from the parallelogram law of vector that the resultant magnitude is square root a square plus b square plus 2ab cos theta. Here I am taking the angle between a and b 60 degree. Here L is basically tells the direction of the magnitude of our resultant. We note that the formula of the direction in parallelogram law vector is tan inverse. A tan is basically tan inverse, remember, and b sine theta divided by a plus b cos theta. The theta is the angle between a and b. Here we will get the value of L. If L less than 0. L equal to minus 1 star L. Now you will understand why we need all this kind of stuff. I will tell you later on, but just for this first we run a program in the first quadrant. You will realize why all these lines are important. So when I run this code, you will see the graph. Here the blue line represents A and B and the orange line represents the magnitude and the resultant. As you can see, the resultant magnitude is 50.6204 and the angle of resultant is 26.329. Now, for example, if the value of A is negative, so we know that when x is negative and y is positive, here I am taking A in the x-axis and taking B in the y-axis. so it lies in the second quadrant. And when I would calculate the value of the L by using of the resultant direction by using this formula, I get the value of L in minus. Okay, but due to that, what will gonna happen? For example, if I run this code and want to see what's the value of L, it's showing me value of 49.106, but we know that when x is negative and y is positive, it lies between the angle range of between 90 and 180, but we got the value of L is 49.106. So we know that it is basically doing wrong. So to reduce that error, what I have done is plus 90 plus L, so that the angle goes to the second quadrant. As you can see, it shows me the right graph. Now another question arises in your mind: why I have typed if L less than 0 minus 1 into L. Now assume I remove this line. Now I run this code. As you can see, the angle goes in the first quadrant and the real value of L now is minus 49.106. The reason that we got the answer in negative is that because one of our magnitude is negative, because of that our answer is, we get the answer wrong. To remove this error, I just multiply L into minus 1 only if L is less than 0, so that we get the right answer. For example, if A is negative and B is negative, then it goes to the third quadrant. That is the third quadrant. So angle must be greater than the 180 degree. Now click on run. As you can see, here we get the graph and we got the right value. Okay. Now let's try to understand how these lines coding. Here 0 x 0 comma 0, it means this is the starting point of a line, and a comma 0, that basically represent the magnitude of the A. Here a0 a comma 0 is representing this. Here a on x-axis and y equal to 0 on y-axis. This point is a comma 0. Again I am going to 0 comma 0, that is the third line. After that b comma b cos radian 60 degree, b sin radian 60 degree, that moves to the this point. Okay, this is the magnitude. This blue line represents A and B. Now this line 0 comma 0, starting point of the resultant, that is 0 comma 0, and the ending condition is r cos radian. Basically this represent x coordinates, and r sin radians, this represent y coordinates. Because of that we got the magnitude and as well as direction of our resultant. I hope you like this video. If you have any doubts and queries, make sure you comment and this channel, and make sure please subscribe this channel. If anybody can donate this channel, I will be very thankful to them. Thanks for watching and have a great day. In the next video I will talk about how to solve let's see what we have next. Resolution of number of coplanar forces. Okay, in the next video I will talk about how to resolution of a number of coplanar forces in Python. I hope you like this video. If you have any doubts and queries, make sure you comment and ask the question. Thanks for watching and have a great day. Namaste. Namaste. In this video I will tell you how to plot equation of a line in Python. So first of all, what I need to do is import SymPy library. So from SymPy import star. Import star means that I will gonna import all the modules that are present in SymPy. So after that I will type x equal to symbols capital S Y M B O L bracket x. Now after that type plot equation. For example, my equation is 5x 5 star x star here means multiply plus 3. Click on run. Here you can see my graph is plotted. Now somebody say, hey, I want to give a range in which this graph is plotted. So what you need to do is comma type x, comma, lower limit -5, upper limit 5. -5 and +5, you can choose the limit as per your requirement. Here I choose the lower limit -5 and upper limit +5. Now click on here. Here you can see the range -4, -5 to 5. If I remove this line, what will you gonna see is here. Now look, -10 to 10. So now for example, if I have to plot more than two equations of a line, so what I need to do is just type x square plus 5. Okay, now click on run. Here you can see the two equations. Now somebody say name those equations, for example. So type legend equal to capital T RUE true, name it as a, sorry, after that line color blue, A1 dot line color R that represent red, A dot show. Now click on run this graph. Here you can see my second graph. To remove this graph, just type show equal to false. Make sure you put comma. Here you can see the graph now properly, and I plotted. So you can use for factorization, and you can also know at which point your y is 0 from the graph. I hope this video is useful for you. If you have any doubts and queries, you can ask, and maybe some people doesn't understand what is mean A0 and A1. So remember, in Python the counting is always start from 0, not from 1. So what I represent A0 is basically this equation 5x plus 2. So what I have done is A0, this is my equation, and change the line color is to blue. Similarly A1, that is my this equation, and I change its color is to red, and legend to basically representing these two things. Okay, so it will easy to distinguish which line represent what. I hope this video is useful for you. If you have any doubts and queries, make sure you comment. If anybody can donate this channel, I will be very thankful to them. Thanks for watching and have a great day.
Namaste. In this video, I will tell you how to plot the variation of temperature within the wall. Okay, so basically this method is also called interpolation. So I'm going to tell you how to do this. So what's the problem is that we have a brick whose thickness is 0.1 meter, 0.1 meter, and there is one side temperature is 100 degrees Celsius, and at the other sides the temperature is 50 degrees Celsius. Now somebody asks that what is the temperature at a distance 0.05 meter. So basically I am going to calculate this temperature. So to find this temperature, I am assuming that the heat flow is a one-dimensional flow. So let's see how does this code work. So first of all, I import my libraries Matplotlib, that is used to plot graph, and NumPy for some mathematical functions. Just remember, you don't need NumPy currently here in this program, so you don't need to use it. Okay, so here T1, that is 100 degrees Celsius. Okay, the left side of the temperature at the left side of the brick, and T2, the temperature at the right side of the brick. L, that is total thickness of the slab in 0.1 meter, and D, that is thickness of the slab where we want to measure temperature. Remember, the thickness of the slab where we want to measure temperature is taken from the left side. Okay, just remember the convention. Now this formula is arising, we know that this formula is arise from interpolation. For those who don't know how does this formula arrive, for example, let's say I show you how this works. Suppose this is the line of my temperature graph. Okay, here the temperature is T1, here the temperature is T2, here the temperature is T. The total distance is L, and I want to calculate the temperature at a distance X. Now T2, just remember, I am sure that you all know the what is tan. So basically I am going to use the tan trigonometry. So what is tan? Tan is basically perpendicular upon base. So okay, so T1 minus T2, this line is perpendicular. Okay, T1 minus T2 divided by its base. Since I am taking this triangle T1 T2, so its base is L. Similarly, this angle is equal to this triangle. Let's change the color for a bit so you can understand. So it's equal to this triangle. You know why the angle is the same? Because of the symmetries. Okay, so again we are going to use tan formula. T1 minus T, remember T, it is a one dimensional, so T1 minus T, T1 minus T, that is perpendicular, and the distance is X, so type X. So from here I just type the expression of T, that is T equal to D, that I am saying X. Okay, here D is currently X, T2 minus T1, L plus what. Okay, after that I am just going to interpolate 0, 0 and just define the point. 0, 0 is basically first, let's make this graph smaller. Now 0, 0, here is the 0, 0, 0, T1. After that this is L, T2, this is L, 0, this is D, 0, this is D, T, and this is 0, T. Okay, here the temperature in Celsius, and this is the graph. So I hope this video is useful for you, and you can also do this thing in advanced form. For example, like I run this code, you can also do this in advanced form. As you can see, when the distance is increasing or decreasing, you can also see the temperature. Here is showing the temperature T. Let's type the code. Temperature in Celsius. Now run this course. As you can see, you can also see the temperature at a particular distance. I hope you like this video. If you have any doubts and queries, make sure you ask in comments, and please like, subscribe and share this video to motivate us. Thanks for watching and have a great day. Namaste. In this video, I will tell you how to plot a shear force diagram, bending moment diagram, slope diagram and deflection. Before I will start telling you how this code works, let's see what is the question on which I program this code. So here a cantilever beam of 9 meter in length has a distributed constant load 8 kN meter applied downward from the fixed end over a 5 meter distance.
A counterclockwise movement 50 kN meter is applied 5 meters from the fixed end. So this end is currently fixed. And lastly, a downward point 12 kN is applied at the free end of the beam. As you can see, the total length of the beam is 9 meter. Here 8 kN meter load is applied up to a 5 meter distance, and a counterclockwise movement 50 kN meter is applied at a distance 5 meter, and a point load of 12 kN is applied at a distance of 9 meter. So let's see how we code this problem. So first of all, I am using a simple physics continuum mechanics beam import beam. This library is basically specifically designed for plotting shear force, bending moment, deflection and slope plotting. So make sure you install this. You just need to install pip install.simpy. If you don't know how, you can just simply go to your CMD and type pip install simpy, and it will install automatically, and after that you can use this code. Now from simpy import star, I basically import simpy import star so that I can use the symbols command. So what basically symbols command do, that it will give it, you can use a alphabet as a variable in your equation. So here E and I declare a variable, and E is the modulus of elasticity and I moment of inertia. Here B equal to beam, okay, that is 9 meter in length, E that is modulus of elasticity, and I that is moment of inertia. So first of all, what I have done is B dot apply load minus 12 9 minus 1. So minus 12 is basically the point load. As I told you earlier, the point load acting downwards direction. If for example, if the code, if it is returned 12 kN instead of minus, so what basically happened, that the load will act in upward direction. So minus represent it is acting in downward direction, 9 represent the distance, so it acts as a 9 meter from the base, okay, and minus 1 represent polynomial degree. For example, if you know, simply write a polynomial, then its equation is minus 12x minus 9. If you have written, if you know about bending moment diagram, then you know how this minus 12x minus 9 comes. Now I am going to apply second load 55 minus 2. Here 50 kN meter is our counterclockwise movement at distance 5, and its polynomial is minus 2. Here I applying the third load, that is minus 8 0, 0. Basically 0, 0 is representing that there is no deflection on vertical axis, and start from 0 and end to 5, and it is a uniformly distributed load, okay. Remember, for a uniformly distributed load you declare 4 variables instead of 3, as you can see in the previous loads. Now B dot BC deflection dot append and B dot BC slope append 0, 0. These boundary conditions introduced an unknown direction force and movement which need to be applied to the beam to maintain static equilibrium. Now here R and M represent reactions at the end, and M is the moment. B dot apply dot R 0 minus 1. Here are the codes, and in the end what you need to do is B dot plot shear force, so it will plot shear force diagram. B dot plot bending moment will plot a bending moment diagram. B dot plot slope, so here you need to give the value of E. So here I give the value of 20 times from 9 I, that is moment of inertia. I give the values. Remember, all our units are in kilonewton and meter. So here question arises in mind, what is mean by B dot load, B dot solve reactions load Rm. So just type here b dot plots sorry okay, now b dot plot, sorry, my mistake. Now click on run. Here you can see the equation of the loads. Here minus 258 raised to power x raised to power minus 2 and 52. Okay, so basically b dot load and these lines solved for directions represents the equations of, for example, shear force and bending moments. This is what these lines do. I hope you like this video. If you have any doubt and queries, make sure you comment. Please like this video and share. Thanks for watching and have a great day.
Namaste. In this video, I will tell you how to plot a centrifugal pump velocity triangle diagram in Python. So first of all, let's see what is our question. So I have a centrifugal pump whose internal diameter and external diameter is 200 mm and 400 mm respectively. The pump is currently running at 1200 rpm. The vane angles at the impeller at inlet and outlet are 20 and 30 degree. Remember, the vane angle at the impeller inlet I am representing by theta, and the vane angle at the outlet angle I am representing by phi. The water waves enter the impeller radially, so it means that alpha is equal to 90 degrees and velocity of flow is constant. It means that Vf1 equal to Vf2. Determine the work done by impeller per unit weight of water. But in this video, I will only tell you how to plot a velocity diagram. Okay, so let's see what kind of things we need and how to approach this question. So first of all, what I have done is that I solved this question. Here's D1 is 200 mm, that is 0.2 meter, and D2 is 0.4 meter, and that is 1200 rpm. Remember, all these conditions are given. Now Vf1 equal to Vf2 and Vr1 equal to Vr2. I assume that. Now first of all, I calculate the velocity at the blade inlet, that's 12.56 meter per second, and velocity at the vane outlet, that is 25.13 meter per second. Now from the inlet velocity triangle, I calculate the value of Vf1. Okay, tan theta, it means perpendicular upon hypotenuse. So I calculated the value. I have know the value of u1 that I calculated from here, and tan theta value is from here. So I calculated the value of Vf1, and from outer velocity triangle tan phi, okay, I have got this value Vw2. Now let's see how to plot the graph. Here D1 is diameter, D2 is the outlet vane diameter, and 1200 rpm. Theta, as I told you earlier, vane angle at the inlet, and phi, vane angle at the outlet. U1 the velocity at the vane inlet, U2 velocity at the vane outlet. Here we use a figure that is from Matplotlib to plot the graph. After that, ax.fig.add subplot. The reason I am using a subplot because I am plotting two graphs at once. That is the reason I am using the subplot command. So here I am calculating the Vf1 as I calculated here. So I just simply write this line Vf1 equal to u1 into tan theta. u1 into tan theta. Here I type tan radians theta. The reason I type radians theta is that to convert the value of theta 30 degree into the relevant number. If I don't type radians, what it will do, it will show in 0.0 something else or wrong value. If those who don't understand, they can watch my previous videos. Similarly, I
calculate the value of VR1. Okay, now here I type title velocity flow at inlet. Now let's see how the graph works. Here 0, 0. Okay, when let me minimize it. Here you can see 0, 0. So 0, 0 is this line. After that u2, 0. Here I know that u2 value is 12.56. So here is the 12.56 and y value is 0. After that I go to the VR1 cos radians and VR1 sin radians. After that go to 0. So it plots my inlet velocity triangle. Now let's see our outlet velocity diagram. So ax2 fit.add subplot. Okay, 2, 1, 2. Basically 2 shows number of graph, 1 shows number of rows, and 2 shows number of columns. Okay, so there are 2 graphs, one column and 2 rows. There are 2 rows. Okay, so similarly I calculate the value of VW2. You can just show here. So I just simply convert this term in a simple manner so that calculate it. Similarly 0, 0. Here is the 0, 0. After that I go to the u2. After that VR1 cos radian, sin radian. After that I reach here. After that I just approach here 0, 0. I hope you like this video. If you have any query and doubts, make sure you ask your question. Thanks for watching and have a great day. Make sure you subscribe this channel. Have a great day. Namaste. Namaste. In this video, I will tell you how to calculate temperature at different points in a slab when there is a heat generation and temperature at the both sides of the slab are same. So first of all, if you don't know anything about heat transfer, then please stop watching this video because this video is not useful for you. If you know how does heat transfer occur with the heat generation and you know how this equation arrives, then watch this video, else this video is useless for you and you will not understand the concept. So now let's try to understand this code if you know about heat transfer. So first of all, what I have done is I import the graph libraries, NumPy, numerical Python libraries and IPyWidgets. Here I considered the slab temperature at both sides is 60 degrees Celsius. Qg, that is heat generation per unit volume, is 80 watt per meter cube and thermal conductivity, that is 1.148 watt per meter Kelvin. Here D is basically the thickness of the slab, that is 1.2 meter. So here first I run the code so you can see what's going on. As you can see, the thickness of the slab is 0 to 1.2 meter. When I decrease the value, I see that at thickness 0.37 from left side, from 0.37 meter, that my temperature is 70.7 degrees Celsius. But at distance 60, I see the temperature is 72.54 degrees Celsius. So the temperature is increasing at the center because of the heat generation. Now let's go back to the code and understand it. Here T is the heat generation equation as I told you. So this equation is to get the value of temperature at a certain distance. As you can see, when I enter the value or move this slider, I get the temperature at a particular distance. Here TTH is basically used to draw the curve. You can see this blue line. This blue line is generated by this equation. I am using this line to basically use in my slider bar. Here the axis, I put the axis limits 0, 1.2, that is basically the x-axis, that you can say distance in meter, and y limit 0 to 80 degree, that is y-axis, that shows temperature in degrees Celsius. Now here a equal to g, a equal to j, b equal to th. Basically plot a comma b0. You see, you are watching this line. These lines are drawn by a and b. Here I give the title of the graph: heat generation graph when temperature on both sides is same. I label the x side, that is distance in meter, and I label the y side temperature in degrees Celsius. Here x comma tth, that is basically is plotting the blue curve line, and plot j comma t, that is basically is doing nothing basically here. This line is doing nothing, and plot a comma b, that generates basically this vertical line, and print temperature at j, that is basically the distance from the left side of the slab, okay, and T is the temperature in degrees Celsius. So I use after that IPyVG interactive plot. After that you saw this graph. I hope this video is useful for you. If you have any query and doubts, please ask in the comments. Thanks for watching and have a great day. Please subscribe this channel because it motivates me to generate more and better content for mechanical engineers. As you can see, there are people who are less interested in coding, but time changes and you need to learn the code. So I hope you like this video. Thanks for watching and have a great day. Namaste. In this video, I will tell you how to plot a smiley face in Python. So this is my code. Let's run it. So here we got the smiley face. Now let's try to understand how this code is actually working. So first of all we need to do is import modules matplotlib.pyplot and numpy. Matplotlib.pyplot is the module for the graph and numpy is the for the math module. Now here C is the line space 0, 360, 360. It is basically I'm using to create a circle. This yellow circle and these two blue circles. I'm using T for this, and TH is 90 to 270 degree. It is basically used to make a arc of the smiley face. Now let's try to understand how this code works. Here x and y are the plots. So 20 into sine radians t cos radians t. This two x and y plot this yellow circle. Now xd and yd are the small blue circles, and xdd, ydd are the arcs, that is 15. Now x comma y, here dot y is yellow color, y xd yd b. Here this line just make only this circle, but I want also this circle. So what I did, I just did minus xd and positive yd, and I got this blue circle, then another eye. Here xdd, ydd make this arc, and x is equal to make sure that it look like a circle. If I didn't type x is equal, what it will do basically, here it shows now me ellipse. So make sure you type x is equal. I hope you like this video. Make sure you click on the like and subscribe button, and please motivate us. Thanks for watching and have a great day. Namaste. In this video, I will tell you how to plot an arc between two lines. So first of all, let's run this code. Enter the value of theta, for example 60. As you can see, here the angle is theta, and these lines are inclined at an angle of 60 degree. Now let's try to understand this code. First of all, we import module from NumPy, import all the files, and from Matplotlib, that is for plotting. Now, theta eval means evaluate. Input, enter the value of theta. Now, t equal to line space 0, theta 360. Here, 0 is the starting point, theta is the ending point, and 360 is the number of points. Okay. I have also made a tutorial what is the meaning of line space in my videos, so you can check out to understand the meaning of line space deeply. Now here R is the radius. Here is the R is the radius. You can adjust the radius as per your length. Here L is the length. That is the total length. That is 60. Here x equal to R cos radians t, y equal to R sin radians t. So what basically happens, here the value of t is 0 to 60 degree, because I enter the value of theta is 60 degree. So x equal to when x equal to t from 0, so it reaches a 0 equal to this point. For example, for cos 0, sorry, 10 cos 0 equal to 10. So here is the point, and sin 0 0. So here we got the first point. Similarly, when the value reaches up to 0, it makes a circle like this. Okay, here I plot the graph between x comma y comma a comma b. Here x comma y basically plots the arc, and a comma b are these two lines, orange color lines. Now let's try to understand these two lines. Here a 0 comma 0, so the line starting point is 0 comma 0, and the second point is L comma 0. So the line goes to the L comma 0. After that, the line again goes back to 0 comma 0, and after that, this point is defined by L cos radians theta or L sin radians theta, so that we get this point. Okay. After that, plot x comma y. It's basically the blue line that plots the arc, and a comma b is the line. And I type x is equal. If I don't type x is equal, what basically will gonna happen, that it will not look like an arc. For example, let me show you 60. As you can see, it not look like an arc. It looks something like else. So to make it look like an arc, just make sure you click on x is equal. Now click run, enter the value, for example 120. Here we got our graph. I hope you like this video, and thanks for watching. Namaste and have a great day. Take care.
Namaste. In this video, I will tell you how to plot a parabola in Python. To plot a parabola in Python, first of all, we need to import some modules and functions. So to do that, let's see how we can do. From matplotlib.pyplot import star. What it will do, it will import all the functions or modules that we are going to use in our graph plotting. Now after that, from numpy import star. This module is used for to use line space command and other things. X equal to line space -1 comma 1 comma 50, enter. Y equal to x square, enter. Plot x comma y. Now what it will happen is that it plots the x comma y graph, but it is not showing here. So type show, click enter. As you can see, it plots the graph. Now if you zoom the graph, you will see that the graph is not very high accuracy, as this kind of thing is not thing that you can see in our parabola. So To make a graph of high accuracy, what we will need to do is uh, just decrease the gap and it will increase the accuracy. Let's try to understand. X equal to line space minus 1 comma 1 comma 5000. Now line space, what it does to do is the initial value is minus 1, last value is 1, and what it will do, it will divide the number of terms up to 5000. For example, let me show the previous value x. Now as you can see, minus 1 to 1, it is total 50 intervals and it is divided equally to reach 1. So this is the work done by the line space. This is the initial value, this is the final value, and the total number of intervals. So this time I am going to do 5000 intervals. After that, y equal to x square plot x comma y show. Now let's check. As you can see, we are not able to see any dots or uh, just turns. It is just a smooth curve. So our graph is well made. I hope you like these videos. If you have any doubt or query, make sure you comment. Thanks for watching. Make sure you subscribe, and if you want to donate, you can also donate us. Link in the description. Thanks for watching and have a great day.
Namaste. In this video, I will tell you how to plot a velocity profile in a circular cross section when a fluid is flowing. So, first of all, let's see what kind of things and library we are going to use in Python. So, here we use NumPy, Matplotlib, and math. Just remember, I am using from NumPy import star. It means from numpy import star. Star means whatever the functions available in numpy, it will import all the functions. And similarly, I'm using matplotlib.pyplot import star. So whatever the functions available in pyplot, it will import all. If you saw any other Python codes on internet, you will see that it is import numpy as. Just remember, I am not using that because it will increase the number of typing word and also your effort. So I hate that kind of thing. So I'm not using from math import star. Okay. Now the first thing here is written P1. P1 is basically pressure at entering point. Okay, so here you will enter the value of P1 in Newton. Similarly, P2 in Newton. Here eval basically what it will do, it will convert the input value into a number. For example, if I don't use eval, what will happen that the input will be taken take as a string, but I want that input will take as a number. So I'm using eval. It will evaluate what the input. Okay. Now mu is basically the viscosity. So I'm taking the viscosity unit as a Newton second per meter square. Uh, just remember, I'm just using SI units. If you want to use pounds or any other units, you can use that. Basically, I'm from India, so we use SI units here. You can use as per your country requirement. R is basically the diameter of the pipe in which the fluid is going to flow. So you will enter here the diameter of the pipe in meter. Okay. Now L is the length of the pipe. So you will enter the length of the pipe in meter. Just remember, make sure you use the units correctly. Any mistake in units will show you a wrong graph or a wrong answers. So if P here I put a if else condition. If P1 greater than P1 less than P2, it will swap the value. Just remember, if P2 greater than P1, what will happen? It will plot a wrong graph. and nobody likes it, even your research work. If P1 equal to P2, what will happen? We get a zero value. As you can see, V max P1 minus P2. If P1 equal to P2, we will get 0. So it's a obvious thing that we will get no graph. N is the number of basically the gap. For example, R line space minus R to R N. You will understand what this mean when a graph will be plotted. V max is the maximum velocity of our fluid flowing, and V is the average. So we use Vmax. To understand this formula, what is written here, please go into my description. There is a blog link. If you go there, you will understand what it means more uh, better and understandably. T and scatter. Basically, I'm going to plot a scatter plot. So along x-axis, I'm plotting velocity in meter per second. Along y, it is diameter and data. So let's run the program. Click on run module. Click OK. Now enter the value of P1. Let's say 5000, and enter the value of P2. Let's say 4700. Just remember these units are in Newton. Okay. Enter the value. Enter the value of viscosity 0.1. Enter the radius of the pipe 0.6. Enter the length of the pipe. Let's say 100, and it plots the graph. You can see minus 6 to 6. So 0 to 6 is the R, and 6 to 6, it's basically the diameter of the pipe. So here you see the velocity here is 0 meter per second, and increasing up to 2.5, and here you get the maximum velocity. Okay. Now as I told you that the work of N is the number of gap. For example, as you see these number of dots, these dots are basically represented by n. If higher the value of n, higher will be the number of dots, and it increase the accuracy. But just remember, if you have a weak PC, for example, less RAM or possesses weak, I prefer don't use high values, use less values, because it will make sometimes crash your PC or something like else problem. For example, in my case, the RAM of my laptop is 12 GB near about, so it will works fine in for any kind of programs. If you have 8 GB, it will also do run this kind of program easily. Okay. I hope this tutorial is useful for you. Make sure you click on like and subscribe button. If you think this video is useful for you, and if anybody helps to donate this channel financially, I will be very thankful to them. It will be very helpful for me. Even a single penny from you is very helpful for me. Thanks for watching. For any other queries, make sure you comment, and link is in the description for more information. Thanks for watching and have a great day. Namaste guys, in this video I am going to teach you how to upload a file in Jupyter. So basically I am going to upload a Jupyter file and show it in like this format. So what you have to do is simply just run this command, click on upload, select the CSV file as per your requirement. Okay, so here I am going to open shopping data, click open. After that run this command. Okay, so here you can see I got the output of my shopping data. So similarly in that way you can open any kind of file. Just in case if you want to open a text file or a PDF file, just change the format to PDF or CSV as per your requirement. If you want to open more than one file format, then type these things. Okay, again it's up to you. This method is suitable. I highly recommend that you create a function as per your requirement to use this, okay, so that your line of code will become shorter. I hope you learned something from this video, and if you want the code, check out the blog link in description. Thanks for watching and have a great day. Namaste. Namaste guys, in this video I'm going to teach you how to make a crank mechanism with velocity and acceleration diagram in Python. So if here is the code, if I run this, so here you can see my crank mechanism. Okay, so this is my connecting rod mechanism. This is my velocity. Basically it is telling the velocity of my crank. Okay, so this is the graph and this is the acceleration graph. And here you can see it stopped at 175 something, because was 80 actually because of this. So if I increase the theta, you see it rotates, and you see the velocity graph it's plotting with respect to theta. So you can make interactive one as per your requirement. Okay, now let's see how does this code work. Before I start this video, make sure that you check out the video or previous link in description, because I've already explained in the previous video that how does these things work. For example, I have already explained how does this crank work. I have explained very briefly and detailed how I use coordinate absolute coordinate system. So explaining same thing again and again, I think it's a waste of time. So what I'm going to teach in this video, how does I plot the velocity graph and the acceleration graph in this video. Okay, so I have basically used this time subplots, okay, for my acceleration and velocity diagram, and there are three parameters. Theta, basically the angle 0 to 360 degree. C is basically the crank radius, and CR is basically connecting rod length. Now let's see how I calculate the velocity. Okay, so basically what I have done is AX2 is basically the name of my subplot, that is the second plot. Okay, and I have given omega C sine radians theta, or omega C sine theta plus sine 2 theta divided by 2n, where n is nothing just crank radius divided connect sorry n is nothing just connecting rod length divided by crank radius. Okay, it is the ratio. The formula I got from R.S. Khurmi Theory of Machines. I'm just giving a reference, but you can see other books as well, other engineering books of theory machines, whatever available in your countries. Okay, so this formula is calculated by inertia method. Okay, so basically I use that formula and calculate these things. For more details, you can check out the link in description. Uh, okay, for these things. Similarly, I have used the formula of acceleration. Okay, here you see I have typed omega with t, and in other case with theta. So just you know that t store the values in arrays and theta store values in just a specific value. For those who are not understanding what is mean by array, for example, here you see, so this is called array type. So this this line basically holds the value like this. That is the reason that helps to plot this graph. Okay, and this holds value like this, and here you can read it. So here you can see read the value of acceleration, and this is the velocity, and this is the distance from here to here, and here is the angle. If I change it, you can see the angle updates and velocity and acceleration as well. uh, I am new to this kind of videos. If I am unable to teach or explain anything properly in this video, just comment on my blog, because I will update my blog as per the requirement of the audience, so you can better understand what is going on. If you don't understand or have doubts what the hell is going on and any queries, make sure that you comment on my blog, because I will update the blog after getting the constructive criticism or feedbacks. Thanks for watching and have a great day. Please give constructive criticism so that this channel can make more and better contents. Thanks for watching and have a great day.